Welcome to Cinema 5. My name is Johannes Dienst. I won't go into my biography here, don't want to bore you to death here. I will talk about real cross-platform workflow UI automation. And we saw in the opening keynote, it's all about Terminators and AI these days. And when we think about AI at the moment, it's about generative AI and large language models. So you can create text, you can summarize text, but who knows something about AI in computer vision? So nobody. You're at the right session then. Because if we talk about computer vision and computer vision in software automation and UI automation, then we're talking about graphical user interfaces. And when we talk about graphical user interfaces, then we have laptops here, we have tablets, we have smartphones, anything we touch. Nearly everything is touch at the moment. This is what we usually interact with. And dating back to 1966, there was a summer camp where they tried to find a solution for computer vision. So let's take 6 weeks and teach machines how to understand our world visually. Turns out we are still at this problem because it's not that easy to understand graphical user interfaces. So when we talk about UI automation, you maybe have seen some cool demos of agents, some call them agents for GPT, where you just say to the agent, I want to fly from A to B, from New York to California, for example, and then they have a browser, and the browser does everything. Finding the perfect flight with the constraints, booking the flight, and you get the receipt per email, and everything runs in your browser. That's not to say easy thing to do, but it all runs in the browser. So when we talk about user interface testing, we're not talking about browser automation. We're talking about tablets, native apps on different platforms, like, for example, the Apple Watch. We're also talking about, when we're going into enterprise context, about legacy applications that run somewhere in the cloud and you only have a remote desktop, where you don't have any structural information to automate on. How do you do this? And it becomes even harder if you think about, okay, what is a typical workflow you're going through? So for example, some data gets entered by a human into a backend application. And this data gets to another person, which edits the data, validates the data, approves the data, and then you have someone at the workstation who needs this information on even another application to do something with it. So if you want to automate this complete workflow, then you have to automate 3 different platforms. This is not as easy. Turns out some frameworks are already out there. So if you haven't checked out a robot framework, I suggest you do this now. Robot framework is kind of a middle layer framework. So you can connect Playwright, you can Selenium, and all those different automation frameworks for UIs. And robot framework just adds a layer like Gherkin. It's written in Python, so you have the Python library. And then you can say, okay, do this, and robot takes the correct library to automate your specific platform. Turns out robot framework and the UI automation for browsers, even cross-platform over Android. For example, with Playwright, you can even a little bit automate Android over the accessibility tree. The frameworks for UI automation browsers are perfect. So if you have a browser application, use these frameworks. But if you have a native application or even some arcane embedded devices or smartwatches, it becomes harder. There are few frameworks out there. But if we go to the framework, what's the problem with native apps? What's the problem with native apps? Turns out we humans, our brains are pattern matching machines. So this is a very simple example from a not so secure landing page, login page. So if we humans land on this login page, we instantly grok the meaning of every element there. So we have a heading, login page, we have a button, and we kind of come to the conclusion, if we click login, mostly for the sake of brevity here, I have excluded the credentials. Yeah, we have a username and a password there, and then if we click login, then we get to some kind of dashboard or profile page or thing. This is what I call a visual selector. So you see it, you can instantly select the right thing. It's not as easy with thumb UIs, I get it, so we come to that later. But when we get to the browser, this completely looks different for a computer or for a framework. So there we have to use a code selector. And the code selector always automates on some form of structure. If we see this as a web page, then it's the DOM, document object model, and the document object model is hierarchical. So if you want this button on the right, then you have to navigate the whole way down and write a selector for it. You can do this with CSS, you can do this with XPath, that works quite well, but you have the problem that every time the DOM changes, you're kind of lost. Because if you don't adapt your automation and it doesn't find the element here anymore, your automation fails. So this is, a lot of people experience this, I talk to, that they have big test suites and the tests become flaky. And they have to put a whole lot of discipline in their development process to not have flaky tests. So, and then the next problem. When we're talking about native apps, or even if you go to Google Maps, for example, we're talking about so-called canvas or 2D plane elements. These are kind of like black holes. They swallow the information, they display the information, but you can't access them. It's just a canvas element. No chance. So you have an iframe there, you have a canvas there. In the canvas, there's just this canvas element. You don't have any XPath selectors, you don't have any CSS selectors. And there are some companies who automate that stuff, and I even saw a demo from Samsung where they had this stylus in a hand and just use the coordinates to navigate through their app. So you can use coordinates there, you can use AI there, and this is a use case for visual selection. The problem with coordinates and AI is, especially in the native space, you have a lot of different form factors, so coordinates fail for different form factors. You have to write a test case for every form factor, and this is basically impossible. But there are already some tools there who allow you to do some cross-platform user interface testing. I want to highlight Maestro here. I can't look into the source code how it's done, but actually they are able to automate Android apps. Then we have Applitools. Applitools trained a machine learning model to recognize layouts, so sidebars, headers, tables, and that stuff. And you can say, okay, does the layout change? This is so if you think about visual regression testing, then you had screenshots and you compare the screenshots, and every time the screenshot is a little bit off, your test fails. That's not happening with Applitools. I tried it and it works very well. You can even define some exceptions for the layout for variable things. That's cool. And we have Eggplant. I'm not sure if it's called like that anymore because it was bought by Keystone, I think. Not sure if that's the right thing. Eggplant does image-in-image search. And you just select a button, for example, like the login page button, and say, okay, find this button here. The problem with image search is it's rather slow because you can't use your GPU for that. You can only use CPU inference, and CPU inference is a lot slower. Okay, back to our cross-platform workflow automation. What are we actually trying to achieve there? So if we think from a tester's point of view or from an automation point of view, and even the example with booking of flights over a browser, what we actually want to do is automate like a real human user would. This is cool for testing because you catch bugs that are usually non-catchable if you're automating on a structure, like modal dialogues or mouse movement or pop-ups you don't see normally if you're automating on the structure. So I want to recognize everything as a real human user would. This means visual selectors, like I described earlier. And I also want to instrument every open operating system as a real human user would. This means taps on your phone, real mouse movement, like this, and also key presses, like real keyboard input. This is what we actually want to do. So this means if we achieve these 4 things, then we can automate like a real human user. We are not constrained by some technology. We are just automating like a user. We can automate anything, even cross-platform. So this means we have to somehow solve the problem of automating operator systems. This is actually really hard. And we need to recognize our UI as a real human user, and this is where computer vision and AI comes into play. So if you think about the segmentation tasks, so the segmentation anything model, Google released an open source model which can identify everything in near real time in a picture. So we can already identify objects to the pixel. So we're getting there in computer vision. And if you do this, if you solve the operating system thing, which is not so easy, but if we solve the UI recognizing problem, then we can automate like a real human user would, and we can do cross-platform automation. Which brings us to AI vision. What is currently possible to automate? So this is a very blurry screenshot of Google Maps. If you check Google Maps, you see there's a canvas element, some HTML in there in this page, but nothing more. And this is a screenshot from a model who is trained to detect text here and buttons and everything that's on your screen, even the menu bar. So you can see there are bounding boxes around the city names. There are even bounding boxes here. So this should be a text field. So basically, we can now recognize the elements like a real human user would. And then we can try to automate. So what I want to show now, because we're on a big screen, can everybody read it? Yes, even the back page is perfect. So I want to not only show the screenshot, but also do some live coding. And let's see if that works out. I have to check if I'm here on the reCAPTCHA. That's a little bit, I'll make it a little bit bigger. And let's see if we can see. Oh, nice. I was too slow. So you see, I'm automating like a real human user. So let's see if I'm faster now. Man, the internet is really fast in here. So this is a typical thing you experience when you're doing user interface automation. There's something not visible here. I just wanted to see the browser, but I'm not fast enough. Let's do this again. Okay. So it is faster than at home. So now we're actually seeing the thing we want to automate. And the fun thing is reCAPTCHA works in a few ways, but the first thing they do is if you're visiting the site, they are setting a session cookie. And then if you say, I'm not a robot, you have to solve this image capture. I already solved the image capture, hopefully, in this browser session. So now I just want to move the mouse to I'm not a robot checkbox and click on the checkbox. And this should identify me as a not robot. So that's what I want to solve here. So let's. So I want to navigate to this page. I'm already there, and then I do a mouse left click, and then I click the checkbox. In case you're wondering why I do a mouse left click, the moment I switch to the browser, I get the focus. This demo, I think it's not even needed, but if some other application comes up, it steals the focus, and then the click just does the focus again on the browser. So you're dealing, if you're automating like a real human user, you're really dealing with the everyday problems of image capture. I remember when I used Cisco WebEx, it was so slow to start up, and I already typed in my VPN password, and then I got a token and wanted to enter the token, and then Cisco WebEx came up, and every day at least one person at our team sent the token to someone else because it stole the focus, and it was really annoying. So let's do this. See if I'm fast enough. Okay. So Google thinks we're automating like a real human user. You saw the mouse movement, that this looked natural. So we are automating the operating system. Cool. So this is not that impressive already. So what I want to do now is do something more interesting. And I have to. And what is an interesting use case I can show here at a conference? I didn't want to automate something I don't have a lot of control over. I chose to automate the two-factor authentication. And the two-factor authentication, yes, I got this comment before. It's not a real use case. You don't test two-factor authentication, but it shows nicely. Take an Android phone, get the TOTP, and then enter it back into the website and be logged in. This is a real nice cross-platform use case, and it works like this. You go to github.com, enter your username and password. Then I have my phone here, which is connected with two-factor authentication application, and then we get the code here from the LastPass app, enter it here, and get to GitHub. So this is the full circle of user human interface interaction. You enter information, you go to another application, you get the information from another application, like the app here, and enter it back into the original application. So if you can do this, you can basically automate everything. Oh, so let's check the code. I prepared it before because if I do live coding, usually something gets awry here. So what we want to do here is, okay, we do the mouse left click, that's given. Then we want to click on the text sign in. So I have to go to better I do this a little bit. Okay. So I want to click on sign in. I enter my username and password. You could steal it because it's in plain text at the moment. And then I go to my, let's see if it's visible. No. So this is my app here. Get this token and enter it when I'm prompted to. So this is what I want to do. So I click on the text sign in, which brings me to the sign in page. Then I want to type in my username. And you can see that the syntax is near the usual natural language. So you say type in into the text field that is below the text username or email address. So what you see here with below are relational selectors. These are kind of new because sometimes you just can't select an icon. Icons are millions out there, and you just know, okay, there's a text field, and you know there's a text field below the text username or email address. And we want to type in something there. And then we do a key press because key presses don't need any inference. And then we enter our username in the same way. Then we press the tab, and then we press enter. This should give us the prompt where we get the two-factor authentication. So you may ask, how do I instrument the Android phone here? At the moment, this is done over the Android development bridge, not debug bridge. We can issue console commands there because it's a Linux system, more or less. And the first thing I want to do is wake up the phone and then open the LastPass Authenticator app. This may take a while, so we are waiting a little bit until my LastPass app is open. And then I do the information extraction. So I say, okay, on my Android phone, get the text that is below the text GitHub, which should be, so here's the text GitHub, which should be this token. So if anybody has done OCR, optical character recognition, there's some funny things that can happen there. So if you have a 0 with a specific font that's a dash in it, then maybe that's an 8. So I'm doing some post-processing here. I take the first element because that's returned, and I replace every white space. So I don't want any white spaces in there because there may be a white space in the middle. And when I get this, I log this code out to see if it's actually extracted correctly. Then I press the tab, and then I want to retype in the code here. Don't want to send it to the backend, into the text field that is above the text verify, which should be the text field I enter my TOTP. And that's it. That should take me to my GitHub profile. So now I have to rearrange a little bit. Also have to enable it. That's enabled. So you're actually believing me that I'm doing this. So where's GitHub? Come on, I have to sign in. Let's remove this. Can I make this a little bit? So I have to sign in. And let's move this over here. So the first time I did this live demo to my colleagues, they said, yeah, you're scripting this. It's not a real live demo. So let's make this a bit bigger and see how that works. So it found the sign-in, should enter my username and password. hopefully, it's extracted the right thing. We can see it on the left. And we were logged into GitHub. And if you noticed, I didn't use anything here with my hands, so I didn't script it. It was not a recording. So I'm quite happy that that worked out. Usually this brings me to the end of the presentation, but because usually something is going wrong, so I'm happy nothing went wrong. So I added another thing where we are heading in the future. So with the advancement in computer vision, if we're seeing even better models getting there, where the main task is to recognize context. So the main problem in computer vision is recognizing context. So if you look at a picture from a visual question answering data set, then there's always this cool picture where a girl is riding a bike in a picture, and on the right side there's a bike and a girl, but they're not related. And if you ask a machine, so what's the relation between these two objects? A machine often is not able to tell, is the girl riding the bike or not? So this is where the advancement in large language models come into play. So large language models, to nerd out a little bit, are using so-called transformer models. And these chopping up information, words, into smaller pieces and setting them into context. And some interesting development happened there. So somebody said, oh, we have these deep neural networks at the moment, convolutional neural networks, which are usually used to do computer vision. Let's do this with vision transformers. So take the transformer approach, which is very good at translating. So if you know ChatGPT, it's extremely good at translating things, summarize things. That's because the models are trained in a way that they take context into account. That's when they talk about context. And do this also for computer vision. And this is where we're actually heading, using vision transformers and combining them with convolutional neural networks to actually get the context, to be better at recognizing things with, for example, the bike and the girl. So it's very interesting to see these developments and work for a company who's actually trying to implement this. And I think what we are going to see is a resurgence of agent systems. So there's already agent GPT with the current trademark problem. Maybe they have to rename this. It's currently beta. And what agent GPT does is says, okay, give me a task, and then it spawns agents, and these agents talk to each other. They are also backed with ChatGPT, so one agent says, oh, that task is so big, I break it down into other tasks, and these agents are talking to each other. And imagine these agents being able to control everything on your operating system, legacy apps, native apps, your workflows, what you can do. If you know Zapier, for example, you can connect any system over APIs, basically. So imagine this on steroids, we can even control your UI. And then, if you add something like real visual selection and real operating system automation, this is where the real power of automation comes to. So where we're heading is getting tasks done autonomously with advancement in large language models, in ChatGPT, and also in computer vision. Which brings me to the end of my presentation. I hope I could give you some inspiration what will be possible in the near future with all the advancements and all the open source models. And I wish you fun at JCO. Do you have questions? I can also take them in German and translate them to English, so no problem here. Okay, then. I repeated. So the question was if you can integrate GPT or agent GPT with Cypress. I'm not sure how agent GPT works under the hood. I didn't look at the source code. I'm also not sure how you can integrate it into Cypress. So this was more like a vision slide where I said, okay, what is the future there? So automate everything, not with structural frameworks, but with visual selection. Okay, again, have fun. Ah, there was another question, sorry. So the question was, you have to re-implement if you do visual selection or with agent GPT? You can integrate this, as I showed, this is code. So this is TypeScript. I think Cypress is also TypeScript. And there's a TypeScript library for Playwright, which is the most popular at the moment. So you can integrate this more or less seamlessly. Okay. Let's see if there's another question. No. Have fun.